This is day 67 of teaching you something new about electronics every day until you become a master. I know everybody's been waiting for this.
This is the world's smallest power bank. It measures in at just under 1 centimetre cubed. Let's take a look at how I built this and the insane engineering that went into it. Take for example this board. I purchased it off AliExpress and it's alright, it does the job. This is the inductor from that board. It's a 55 microhenry inductor and it seems pretty small until we compare it to the one from the world's smallest power bank, which you can see in the end of the tweezers is considerably smaller. So how was I able to shrink it so much? This one switches at about 30 kilohertz, which is why it needs a 55 microhenry inductor. My power bank, however, switches at 2.2 megahertz, which means it needs a much smaller 1 microhenry inductor, which is where the shrinkage comes from. It's not that difficult to build a small voltage converter. The problem is when you have to power that, you need a battery. And with lithium batteries, the smaller they get, the less current they can output. For example, this battery from a Samsung phone, for instance, has a 5000 mAh capacity and a 3C discharge rate. That means the maximum speed you can discharge it at is 5000 milliamps times 3, or 15,000 milliamps, which will just shorten to 15 amps. However, if we shrink that battery down so it's only a 1000 milliamp hour battery, now we can only discharge it at 3 times 1000, or 3000 milliamps, which will shorten to 3 amps. And that's the problem. The smaller we make the battery, the harder it is to get enough current. I was able to find a 45 milliamp hour battery with a 60C discharge rate.
Basically all that was left was to build it, so let's do that.